Okay, welcome back. Lesson 27, proportions and problem solving. So I had to, of course, throw in a little example problem involving one of my favorite things, which is iced coffees. So let's dive right in. A 16-ounce iced mocha caramel coffee at a local coffee shop has 80 calories. How many calories are there in a 28-ounce iced mocha coffee? Well, my hint is you must set up a proportion for this to get full credit. And I have the answer over here, but let's see this done in real time. So I can tell you 80 calories for a 16-ounce drink, that seems a little, we wish, right? It seems a little low to me. But big hint, when writing proportions to solve problems, write the proportions so that the numerators have the same unit measure and the denominators have the same unit measure. So my hint is you always want to be on the lookout for A is to B as C is to D. That should be a D. So trying to, construct something, that is a one fraction set equal to the other fraction, a proportion. So let's go back up. All right. So 16 ounces is to 80 calories. Let's write that down. 16 ounces is to 80 calories as 28 ounces, so we've got to have ounces in the numerator, is to who knows how many calories, and we'll let that be X. Now we know that the cross products must be equal, so you're basically going to now cross multiply and solve. And focus in on the numbers. Don't worry so much about the units right now. So just 16 times X is 16X. And set that equal to whatever 28 times 80 is. Now, if you're in a no calculator course, like my course, you would go off in the margin somewhere and figure that out. Just kind of go off on the margin of your paper. I would actually take 28 times 8 and then just add a 0 at the end. So 2, 2, 4, and then just tack on a 0. It's sort of like the shortcut. So 2, 2, 4, 0 equal 16X. And then we just keep on cruising and solve for X. So we know we're going to have to divide by 16. And then, like I said, if you're in a no calculator course, you're going to have to physically divide that, by hand. So just 16 going into longhand division, 2, 2, 4, 0. 16 goes into 22 about once. Draw the line and subtract. And bring down the 4. 16 goes into 64 4 times. Evenly. Bring down this last 0. 16 goes into 0 0 times, and voila, 140. So we have the answer. So that's how we arrive at the 140 calorie mark. So intuitively that makes sense. I mean, if you're taking in more ounces, you're taking in more calories, right? So we know the calorie mark has to go up. So 140. Wouldn't that be great if you could drink more and less and end up with less calories somehow? But sorry, the pen's being fussy there. So just don't forget to label your final answer. So 140 calories. And I usually go back and look at the sentence that was asked, revisit the question, how many calories are there? And we say there are 140. All right, let's try the next one. Similar triangles. Similar triangles are found in art, engineering, architecture, many, many places. If it's been a while since you've heard the word similar, it doesn't mean congruent. Means they have the same shape, but not necessarily the same size. So note to self, corresponding sides are proportional and corresponding angles are congruent. So that's just a little note if you're rusty. So let's use what we know about similar triangles to help us solve for x and y in this problem. So my hint is, this is going to be, to solve for x and y, this is going to be a two-step problem, and the second phase will involve Pythagorean theorem. But phase one, we're going to go like this. 6 is to 4, right? So 6 is to 4 as 8 is to x, right? So 6 is to 4 as 8 is to x. And just make sure you're being consistent in how you set up that proportion. Then we're going to cross multiply and solve. So 6x equals, and you notice you're equating, the diagonals, you're equating them. You're not putting them on top of each other, setting them equal. So 6x equals 32. So therefore x equals whatever 32 divided by 6 is, which is obviously not a whole number. In fact, it's 5 2/6, 5 2/6, which is the same thing as 5 1/3, which is the same thing as 16/3 if you're thinking in improper fractions. So, long story short, we figured out what x is. X ends up being 5 1/3. You could say 5 1/3 as a mixed number, or you could say 16/3. All right. Now, we need Pythagorean theorem to help us solve for y. Now, if it's been a while, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. We have a right triangles, so you may be thinking about a squared plus b squared equals c squared. I'm just saying it in easy language. Leg squared plus leg squared equals hypotenuse squared. So let's kind of see if we can use that to help us solve for the, and by the way, from here to here is the hypotenuse. So just make sure we're plugging and chugging everything in the right spot. So 4 squared, that's one of our legs squared, plus our other leg, which we just figured out was, 16/3. So plus 16/3 whole thing squared has to equal the hypotenuse squared. So now, from there, if it's not sort of pretty numbers or a perfect square, it's okay to use the calculator. Let me hit pause as we do that. Okay, so we can literally just key most of this in. Well, 4 squared we know is 16, so 16 plus 16/3 squared is something. Okay, now let me record that. So 44.4 repeater is y squared. Therefore, y must be the square root of that. Now, I did want to show you something. If we hit math, frac, aha, so we will get 400 over 9 equals y squared. Now, I did just want to mention something here. Notice 400 is a perfect square. Like, what times itself makes 400? Well, 20 times 20 makes 400, right? Notice 9 is a perfect square too. So I did want to say we could actually do this problem. We could take the square root of 400 over 9. We could do that, without a calculator. So note to self, perfect squares. We can take the square root of both of those without a calculator. So again, square root of 400 is 20. Square root of 9 is 3. So 20/3 would have been the hypotenuse of that triangle. And I always say if it's a problem where they're really fussy about the units, or where you have units, and here it was centimeters. We're assuming the whole thing's in centimeters. So I always kind of go back to my drawing and throw it back in, go back to the drawing board, so to speak. So 20/3 centimeters. All right, hope that helps. So that was kind of a double whammy, because I'm just going to highlight that. We had to set up a proportion. Phase one was we had to set up a proportion, to solve for x. And then phase two was we had to use Pythagorean theorem. And let me highlight that. We had to use Pythagorean theorem to solve for y. Okay, good luck out there. Oh, I lied. I was about to say one last problem. If it takes a grad teaching assistant 3 hours to grade 20 papers, how many papers can she grade in 8 hours? Classic set up a proportion problem. I'm just going to do that one real quick. So it takes her 3 hours to set up to grade 20 papers. Is as 8 hours then she could grade a lot more papers. How many? We don't know. We'll call that X. So now we've set up our proportion. And big note to self, notice hours in the numerator, hours in the numerator. You want to be consistent with your units. And then go ahead and cross multiply. And then when you cross multiply, just focus on the numbers, like 3 times X is 3X. And 8 times 20 is 160. And whatever 160 divided by 3 is, and we can round that to the nearest whole number. For time's sake, I'll just key that in. 160 divided by 3. So 53, so to the nearest whole number, about 53 papers. So if I'm putting money on it, she could grade about 53 papers in 8 hours. All right, that's our last slide for today. Hope that made things easier with your proportions.